Okay, cool. Let's start. Thank you very much for being here. It's an honor for me to have the chance to attend this prestigious event and to have you as an audience. I hope you enjoy it. I am Alejandro Stornelli. I am coming from Argentina. I am the Global Head of Quality Engineering at Globant. And I've been in the event presenting Magnify, which is one of our quality-related products that is basically a product that can bring you value in all your test automation strategies, specifically in the visual validations, okay? So today, the idea of this talk is to explore what AI, generative AI, means for software testing. First of all, we will be defining some concepts so we all talk in the same language. So I will be repeating some words during my presentation, and it is important for you to definitely understand what I am referring to. And we're also going to take a look back and see where are we coming from, understand where we are at this time, and we can expect from the future. But the main idea of this presentation is to get a little bit deeper into what AI means for the software testing industry. That's the very basic goal of this chat. So, first of all, let's say, what is AI? Artificial intelligence refers to systems that can mimic intelligent human knowledge. So, human intelligence is a wide concept, and I think it's worth to spend a while trying to understand what that means, but that is out of the scope of this talk. I am not an expert on that. So, yeah, but human intelligence is a wide topic. The idea of having systems that can mimic that human intelligence is what brings us here, okay? So, AI is the ability of machine to perform tasks that would normally require human intelligence so far. Which are those tasks that normally requires human intelligence? What kind of task I am referring to? Well, basically, learning, reasoning, solving problems, have perception, and process natural language. So those are the very basic concepts behind AI. We are referring to AI to systems that can perform such kind of tasks, which are not the ones that one believes is part of what we do when we do programs. But yes, now we have systems that can have that ability, and we need to take advantage of them. Three key concepts to make sure that we all have the same understanding. So I already defined machine learning, but basically, machine learning is the ability of systems to learn from data. I will be referring to that several times. Learn from data. Deep learning is a subset of machine learning that basically uses artificial neural networks to model and solve problems. And neural networks are algorithms that are modeled in the same way that the human brain works. So we are trying to create systems that can learn, can perform tasks that would normally require human intelligence by modeling those systems in the same way that our brain is modeled using artificial neural networks. So that's the basic concept behind it. So another important thing that I consider relevant is that when using AI, we can use AI in a huge amount of different types of, to solve different types of problems. But mainly, I would say that the real advantage of using AI and not doing investments that are worthless are when we have we cannot program the rules. There are so many factors that affect the solution that program the rules is just too expensive. So that kind of problems are the problems that AI can solve in a better way that we can do using regular programming languages, for instance. If there are too many factors, or if there is too much data to process in order to get those outputs, then AI is the perfect candidate. So how we get here? AI is not a new concept. 70 years ago, in the 1950s, there were systems that can play games, like checkers and chess. So at that time, back in, a long time ago, we were using somehow machine learning to perform these kind of tasks. Then, in the 60s, we started to have a way to process natural language. That was a big milestone. At that time, we have a software called ELISA that was able to understand and generate human language. So we were able to simulate human conversations using that software. We are talking about more than 60 years ago. In the 60s and the 70s, we started with robotics. We have robots that work in assembly lines, perform tasks in the space exploration industry, and then we have a big milestone, which is the Stanford arm. Stanford arm is a robotic arm with 6 degrees of freedom that was programmable to perform several kinds of tasks. That was also a major advance in machine learning. So in the 80s, we have decision-making abilities of human experts being the trend. And we have that software, Mycin, which was able to diagnose bacterial infections based on data. So in those years, we started to mimic human expertise on doing things that normally would require human intelligence. Then in the 80s, we started to analyze and interpret visual information, while computer vision became a powerful area of investigation. Then we have in the 90s, we have developed machine learning, again, training computers to recognize patterns and make decisions based on data. I know if, I think that many of you would remember, I was young, but not so young. In 1997, Deep Blue, which was a software from IBM, defeats Garry Kasparov in a 6 games match in chess. So by those years, we started to understand that software can beat the major experts in some area in some way. And that was another big milestone for the AI. Then we developed a huge amount of good work around neural networks in the 90s and the early 2000s. And in 2010, deep learning becomes a dominant force in the area. Now we have, Siri, Alexa, Google Assistant, Netflix, Facebook, blah, everything. All the most popular applications that we are using today are somehow leveraging AI. So, but what happened? Why now? Why the hype we have today around AI? Well, there are several factors, but the main factors, I would say, are these 4. First of all, computing power. The exponential growth of computing power enabled us to process large amount of data and train complex models much faster than before. So that exponential growth on computing power is the factor number 1 behind the hype of AI, definitely. We can do now things that some years ago were almost impossible even to imagine in terms of our capacity to process large amount of data. And process large amount of data is what you need to train AI models. And that's what we are talking about. Also, we have a huge amount of data available. There are devices and sensors everywhere that are continuously generating data. All those pieces of data are available somehow to train models, so we have a virtuous cycle there. More computing power, more data available, more capability to train our models. Of course, funding is a very important factor. Both from public and private parties, they are investing in AI because they see that there are a huge amount of opportunities. So new applications, new technology are being developed everywhere all the time because now we have the computing power, the data, so the investment makes more sense today. And of course, we have better and more efficient algorithms widely available. It's not something that is weird to find. I mean, you can go there and use algorithms that are freely available for you to use, build your models, and train them. Those algorithms are completely available. So before moving into the most relevant topic, I will spend a minute on analyzing two very related but different concepts, which are AI and generative AI. When we are talking about AI, we are talking about systems that can perform tasks, again, typically, that would typically require human intelligence. When we're talking about generative AI, we are talking about a subset of AI that focuses on creating new content. So we are using AI, but for some specific purpose. New content such images, text, video, audio, you know what I'm talking about. That part is probably the most relevant area of research today. Also, a difference is that AI, in general, uses supervised learning, and the algorithms are trained on labeled data. This is a plane, this is a plane, this is a plane. Now you are able to detect a plane because you find a pattern, and now you know this is a plane. That's the label. On the other side, generative AI uses unsupervised learning with unlabeled data. There's no need for us to tell this is exactly this. The algorithm will learn with unstructured data. So both relies on complex algorithms and machine learning techniques, and both are used to solve problems and create new value in all the industries. Generative AI is a subset of AI focused on creating new content. So what about testing? That's why we are here. So we have plenty of opportunities for the software testing industry while leveraging AI. Probably first of all, efficiency, because AI can definitely help on automating manual and repetitive tasks. That's the main reason that AI will definitely impact forever the software testing industry, because there's a lot of manual and repetitive tasks in the testing software industry that we can get rid of if we adopt and use properly AI techniques. I will talk about that a little bit more later. AI can generate, again, new test cases, new test data, so we will increase coverage. We all know that all the software that is out there that is buggy is because we cannot achieve 100% coverage in general. 100% coverage is an ideal. It's not something that can really happen in general. So AI will give us the chance to improve our coverage by learning and suggesting new scenarios in which we will be testing our software in ways that we can even imagine if we do not have that kind of assistance. Of course, velocity. We will be able, given all this, I mean, we will be able to identify software bugs much earlier, and we will be able to fix them earlier, shifting left the problem of identifying and fixing bugs, which, you know, it's probably the most time-consuming task that we perform as software testers. Again, reduce costs. Velocity means less cost. And another thing that AI can do to reduce costs is to find patterns into the test cases that we already have developed and saying, well, these test cases are not relevant. There you have redundancy. They can detect, I mean, we all know that in our huge suites of tests, we normally have validations that are performed by several tests, steps that are performed by several tests. So what if we have someone that says, you don't need to run this test case. This is already validated, but this other one. So get rid of that. So we will be increasing the efficiency and reducing the cost of testing in general. So more coverage, early defect detection, automating repetitive tasks. That means improved reliability and quality of our software. But specifically, what I am talking about, I consider that the main areas in which AI and generative AI specifically will give us a huge help is on these things that you can see there. Test cases generation. What if we can train models on saying, well, these are our functional requirements. Can you give me a set of scenarios that can ensure that those requirements are met by the software? Well, that's exactly what a generative AI can do. And you know that test cases generation is probably one of the most, again, time-consuming tasks that we perform. What if you don't need to start from scratch? What if you can start from a suggested suite of already defined test cases by someone else, the AI, and then you see, well, this is not covered yet. I need to add this. I will modify these ones. But generate something is much more expensive than adjust and improve, you know. So that's one of the things. Test suite reduction. Again, redundancy is one of our most, one of our worst enemies. Because when we are spending and investing time on doing things that we already did and are not adding any value, we are just wasting our time. So reducing the amount of test cases that need to be run because we already have those validations performed by some other test case is truly important. And also, this is related to green IT. The less resources you need to run your test cases to certify your software means that you will be spending less energy on doing that. And energy, you know, is a very important thing to take care of. Fault localization. So AI is good and say, okay, you are modifying this code, and this is the way you are doing that right now. I learned from the vast amount of data that this can be a source of problem. Root cause analysis is something that can be assisted by AI saying, be careful with this. I learned that this code can be buggy because I already detected some cases and I learned from it. And in case you learn enough, the AI can also automate the fixing of those bugs. Well, this is normally code that can be turned into this other code that we know is better because we already learned about that. Test data generation. I mean, most of our testing strategies are data-driven strategies. We are used to run the same test cases over and over again with different data to perform different validations and to provoke different behaviors in our software. So to generate all that data that we need to do that is very expensive, and AI definitely can learn from the data that we're using and suggest new sets of data to do data-driven testing. So impact analysis, I already said that. Bugs prediction, okay. AI for sure can learn on how to detect code that is prone to be wrong. It's like, okay, I have seen that before. I know how this is going to end. And at least suggest us some actions, or even take the decision and automatically fix that. Another thing that AI can probably do is to automate the execution in an autonomous way. They can learn on how, based on the structure of the application, well, these are the probably flows of the application. These are the functional flows, because from this page I can go to this one, and then I can go to this one. So they can automate somehow the way we navigate the applications and suggest flows that can autonomously be executed and release us from the need of at least executing the regular, most common, happy path test cases, okay? It's fair to say that, remember, the traditional testing approach is something deterministic. And now we are talking about something that is probabilistic. So when AI will say, well, this may be wrong, it's not 100% wrong, but maybe it's wrong, and we need to take care of that. We are talking about something that is probabilistic. That's the best difference, and we need to change our mindset and say, okay, this is a suggestion, probably rather than a decision. We are going to be the ones that need to take care of the decisions based on those suggestions. Okay, so what is going to happen with us? Which is the future role of software test engineers? Well, the main thing about this, what I think, is that we will be moving from executing manual and repetitive tasks and investing a huge amount of time on such things to more high-level and strategic tasks that really requires not necessarily human intelligence, but human judgment and expertise. AI is good as mimic human intelligence, but judgment and expertise are two different things. Those things are always going to be part of our job. And when I say high-level and strategic tasks, what I am talking about? Mainly design and execute test plans. Test cases is a fine-grained thing, but test plans, let's do this type of testing on these artifacts during this time. We have a schedule, we have due dates, we know which is important. We can prioritize testing tasks based on our needs, and that is something that will always need human intervention, in my perception. Doing risk management, again, when you are dealing with a software and a tight schedule, as we normally do, you need to deal with the fact that there are risks, and the risks, the prioritization of the risks is on our side. I would say, I need this not to happen at all, so I will take care of executing the test plan related to this part of the software, and probably I will not necessarily invest so much time on some other parts. But that is a risk management that is really hard to do, because it's, again, based on our experience, on our expertise. Result interpretation, I mean, AI will always give you suggestions, will give you outcomes, results, but not necessarily, again, copy and paste is going to be just enough. Sorry, but not. The idea is that we need to take care of interpreting those results and converting that into actionable items. With this, I am okay. I am not so convinced about these results. I will probably learn more about, or let the model knows more about something to have more adjusted results, because that interpretation is always going to be on our side. The definition of test automation strategy, what to automate, when, which tool, how that thing is going to connect with my continuous integration pipeline, that kind of things are always going to be part of the decision that we need to make. Probably we can get assistance from AI. I'm sure about that. But the decision is going to be on us, because the tools, the available tools, will always be helping us in the future to have new options and better options. Continuous learning, we will need to learn about the current status of these tools on a daily basis, because all the time there are new tools, there are new techniques that will be helping us to create better test plans, but we need to know about them, and we need to know how to apply them to our specific business. And there are also some kind of testings that, again, will require a lot from our side. Exploratory testing, for instance. Exploratory testing is something that relies on creativity and intuition. And that is, again, something that is very part of our capabilities. Not necessarily the AI is going to be very good at this. And again, UX testing, usability testing, know how an end user will feel while using the software that we are developing is going to be mainly on us, because we are users, and we know how users feel when they are using the features that we have developed, or our team have developed. And it's very hard to delegate that into AI. So that's my perception. One very important thing about AI is that there are a lot of ethical considerations behind it. It's not so easy to say, okay, I have AI, it will learn, it will take decisions, I will be here just in case you need something from me, bye. It's not like that. Why? Because, first of all, bias and fairnesses. I mean, models can inherit bias from the data they are training on. And that can lead to results that have biases, and that is dangerous. So we are going to be the ones that needs to ensure that the models are trained on diverse and representative data. We need to avoid that, and the way to avoid biases is by ensuring diverse and representative data for the models to be trained on. Privacy and security. Those models will be trained on data that may be sensitive, may be confidential, and we cannot just say, okay, I know what the AI did, but yeah, we are responsible for the usage of sensitive and confidential data. And to follow the regulations, there are many regulations about data that we need to ensure. We just not can rely on AI to do something that we don't know what are the outcomes. We need to ensure that those sensitive and confidential data will keep confidential and secure. Transparency, explainability. I mean, it's really hard sometimes to explain to some not necessarily technical stakeholder about the decisions and the suggestions and the outcome of AI. So we need to keep explainability at the top level. We need to ensure that everybody, all the relevant stakeholders, will be able to understand the outcomes of the system that we are creating by explaining them how the AI reached some conclusions. It's not just say, I was not the one that decided this, sorry, but no. We need to be very careful on learning and knowing how to explain the outcomes of AI. Accountability, responsibility. Who's going to be the ultimate responsible for the decisions made by systems that heavily relies on AI? We, as humans. The idea is to ensure that we know that what the systems are doing, because the accountability is on our side. And also, we need to, about human oversight and intervention, we need to ensure that the outcomes of the systems relying on AI are ethical, and the usage of AI is ethical. We cannot just let it go and say, okay, I am not going to validate the results, and I'm going just to let it go because somebody else is taking the decision. The data is there, the algorithm is there. No, we are the ones that need to ensure that AI is being used ethically. Okay, so in concluding, what is the future of software quality? We will probably get rid of manual, repetitive, and error-prone tasks. That's going to be happening. That is already happening and will happen more and more in the near future. That way, we will be focusing on some more strategic tasks. We will reduce time and cost of software testing. Then we will be able to increase coverage and the depth of the testing because we will be saving time that we can invest on creating new scenarios, imagining new ways of testing our software, and creating more in-depth test cases to ensure that our software is functioning okay, even in scenarios that are not the regular ones that you can imagine while you are creating a first level of test cases. That is going to be part of what the AI will be assisting you. Then we will be able to detect defect earlier. And we will be able to fix those earlier too. So we will be shifting definitely left the detection of the bugs and the fixing of the bugs. That is going to be also saving cost. Then we will have more accurate software. We will be reducing time to market and performance and security and reliability because we will be gaining time to perform more tasks that we normally didn't have enough time to do. That will lead us to provide our users with a better experience, and we will have, in general, at the end of the day, an improved value and a better impact on software on people's lives. You know how important it is to have software that really helps us, and how annoying it is to have software that I don't know what it's doing. We are going towards that goal. Enhance the experience of the people using the software that we are creating. So this is my last slide. Then I will be answering some questions. I think we will have around 10 minutes for that. In general, what is the future of AI in software in general? First of all, the advances in natural language processing are outstanding, are amazing. So we can expect to have improved chatbots, better virtual assistants, and better software to translate software, to translate text. We will have in the computer vision area, we will have more accurate facial recognition, better surveillance systems, and better self-driving cars. Improving all those capabilities will be possible with the computer vision advances that are happening today. In terms of generative AI, we will be able to build applications that create music, games, images, video more easily. Regarding healthcare, we will have more personalized medicines, better image analysis to do diagnoses, and better capabilities on drug discovery. And drug discovery, we all know, is a critical area of development in the healthcare industry. With automated systems, we will have better logistics. We will improve our supply chains, and we will have what is called smart transportation. We are all the time buying things. We need transportation everywhere, all days. That is going to be definitely improved with this automated system. In terms of robotics, we will have much more options on manufacturing, construction, and exploration. Around social media, we can expect to have more personalized content, more personalized messaging. And in terms of reinforcement learning and game theory, we will have more intelligent decision-making systems that will, for sure, help us on business and finance. I think that will be democratizing the way we can use the money because the decision-making will be easier with these advances in reinforcement learning and game theory. That is basically all. So now I am open to any question that you may have. Yeah. I cannot hear you. The developers?
Like the software development engineers and tests, where are they going to go in terms of AI?
Yeah, they will be definitely the ones that will create the software that will be leveraging suggestions on AI. I mean, what if you create a bunch of code for automated tests, for instance? The same applies. I mean, that code can be buggy, that code can need more data to run. So in general, automated testing is a software development task, and the same rule applies. I am assuming that all the test automation engineers will have this kind of assistance to improve the quality of the code, and also we have a better ways to measure the coverage that we are providing while automating tests. So I think that those are basically the main facts. When we automate these cases, we are normally worried about the quality and the maintenance that our code will need. And I think that self-healing will be something that will be assisting us and say, well, now you have all these UI elements that change the shape, the locator, the position, the ID. So you can fix them, they can suggest you ways to fix them, or they can somehow fix them automatically and provide you a suggestion on how to modify and update your test code to be sure that your test will continue running.
Okay. And then I have one other question.
Sure.
So you were referring to the AI in healthcare. So with the pharmacy prescriptions, I guess, are you talking about like interventions, like what happens today where you have a pharmacist, right? And then you might have somebody that's monitoring it from the healthcare industry and say, hey, instead of maybe doing this drug, we want you to do this drug? Is that what you're referring to?
Yeah. Sorry.
So they can hear you online.
Sorry. So with AI in healthcare, so I just want a clarification, I guess, in terms of the prescription. So are you more referring to like an intervention that we call it in healthcare, where you have there's software out there right now that will say, we have people like pharmacists looking at this stuff at like the healthcare, like a health insurance company, and then they provide recommendations back to the pharmacist to say, hey, this one might be a little bit cheaper, and you might want to recommend that next time. Is that what you're kind of referring to?
Yeah, not necessarily just that. I think that the best way to present the advantages of AI in healthcare is to establish better diagnosis. Okay. Because when you have a patient and that brings you symptoms and say, well, this guy has this and this and this, and this is the history. So if you have an AI-assisted software that can say, okay, with this history and these symptoms, this guy maybe has this problem, and will give you the chance to ensure that that is the actual problem. But now it's hard, at least for me, I live in Argentina, to go to a doctor and say, okay, this is my whole history, now I have this, and not be treated as something definitely new. There are systems that can learn from my private perspective, which are the things that have happened to me, and now with the symptoms that I have, what is happening now.
Okay.
And improve the treatment that I will receive.
Got
improve
it.
The efficiency.
That's great. Thank you.
Thank you.
I have a question along those lines. So personalized healthcare and taking the longitudinal patient record, if you will, that's been a problem for some time, right? What is generative AI versus older AI just before October 2022, before the world changed? What is generative AI's contribution to getting us closer to
No,
those
the
things?
contribution is mainly related to AI in general. This is
Right.
not about
It's AI in
generative
general.
AI.
Gotcha.
AI in general can learn from data, mainly your particular data,
Right.
and now we have an individual that has this history, these symptoms, but I'm not considering generative AI the way we are going to achieve this. This is AI in general.
AI in general.
Yeah.
Okay, I got you. I can see generative AI perhaps looking at the corpus of information and making better correlations and maybe
Yeah, and presenting the
against-
information. What
Yes,
if you have
presenting it, yeah.
your historical medical data that is absolutely something that we cannot understand at all in general, and request generative AI to present you those results in a
understandable,
yeah, in an understandable
layman
way.
terms,
That
yeah.
would be a good application of generative AI. Yeah.
I have a question about the future, projecting this down the road many, many years, where if AI is if we're teaching machines from our own data and they're giving us recommendations based on that data, and then that goes back into the recommendation, it's an infinite loop, how are we not just going to dig deeper and deeper into the rut of the way we do things now? How do we...
That would create a bias.
Yes.
Yeah, that's why I was talking about the very importance of having diverse and representative data. We cannot just let the models learn from something that just happened some time ago and new things that are happening based on what they are already suggesting. We are going to be responsible for creating the data sets that the model needs to learn and adding those data sets new information that become available from other sources. We cannot just automate the provision of the data that the models will use to learn. We need to take care of the data and maintain that representative and diverse. Yes, it's not just, because if not, it's just, we are not going to move anywhere. Mm-hmm. We are going to keep this like this forever. And of course, that is a very valid concern. And I have heard about that concern many times. And what I feel is that provisioning data for the models to be trained is going to be one of the top, more important activities that we can do while we are dealing with AI. And it's very difficult. We have a ton of data. I mean, data is being generated everywhere, sensor, devices. I already told you about that. But selecting the appropriate data for those models to be trained is going to be on the data scientist field, and we really need them to ensure that data is useful, diverse, and representative. Yeah. Okay. Any other question? Something in the virtual space?
So we do have a question from the virtual audience that say, what are some challenges and opportunities for the native, hybrid, and or web mobile app testing with AI?
I mean, almost all the things that I already mentioned are things that apply no matter if you are developing a web page or a mobile application. The capability of the software to be tested using new techniques based on a new tool based on AI that can suggest you new ways of using the tool, using the app to find new scenarios and getting deeper into the testing are also applicable for mobile applications. It's nothing different from the other ones. The important thing is that the particular test cases that we all know that we need to run while we are testing things that happen on a mobile are still there. So we need to validate that not only the functional flows are there, but also things that are particular for the cell phones or mobile devices, like battery, internet connection, and all, GPS, all that kind of things. Yeah. Okay, I think we are on time. Thank you very much for being here. I really appreciate it.